I am Joseph of Digilytic Solutions. I am a consultant, trainer, speaker, and a book author. Welcome to our course, Deep Learning Mathematics. In this lesson, we will learn about how to multiply matrices and vectors. At the end of the lesson, you're expected to identify the process of multiplying matrices and vectors, perform the operation of multiplying matrices and vectors, and appreciate the uses of matrices and vectors in deep learning. In our last lesson, we learned about the nature of matrices and tensors. We have learned that a tensor can be a scalar, a vector, or a matrix. We also mentioned that a matrix is a 2D array of numbers, so it means that it is identified by two indices instead of just one. With this, we learned how a matrix should be written. As to tensors, we learned that it is an array of numbers arranged on a regular grid. We mentioned that it is the most general term since it is multidimensional. If you missed lesson number 3, the link is given in the description below so that your study for this lesson would be more meaningful. You may pause this video and come back if you're done with lesson number 3. So everybody knows that we have 4 basic mathematical operations, unless of course for some reasons you don't know any or all of them. So for some excusable reasons, maybe for other persons may not be able to know some of them. It could be because of lack of education or whatever legal or acceptable reasons. So let me enumerate them. We have addition, we have subtraction, we have multiplication, and of course we do have division. So one of the most important operations involving matrices is multiplication of two matrices. So we have the statement AB equals to C. So the statement represents this operation. So this is the multiplication of A and B that results to C. So we have here 3 letters. So maybe you would like to ask me, what are these letters for? What does each one of them represent? So A is one matrix and B is also another matrix. So it means that the matrix product of A and B is a third matrix, which is C. Okay? So for the product C to be defined, certain requirements must be observed. So it is not just that we can just multiply A and B, whatever nature they have, and anytime we can do. No, because we have to follow certain requirements and we have to be mindful of them. So the first requirement is that A must have the same number of columns as B has rows. So for example, if A has 2 columns, so if A has 2 columns and then B needs to have 2 rows too. So for example, okay, 2 columns for A, of course B needs to have 2 rows so that we would be able to comply with the first requirement. So if this is 2 and then this is 1, we cannot do that. If this is 1 and this is 2, we cannot do that. Okay, as far as the first requirement is concerned. Now let's go to the second requirement. The second requirement is that if A is of shape M by N and B is of shape N by P, then C is of shape M by P. So let me write that. A is, we have A, so we have to make this bold because we said in our last lesson, lesson number 3, when we name a matrix, that name should be in bold typeface. So A, M by N, and then we have B, N by P. Okay, so we learned in lesson 3 that the first letter is the row and the second letter is the column. So we're talking here of this one, the superscript. So we learned that. Let me use another color. I think blue is better. So this is the row, column. Okay, column. Okay, so what shall we do in here? So if we have, for example, let's have substitution of real numbers. So for example, we have 3 by 2, which means it has 3 rows and 2 columns, and then B is 2 by 3, which means that B has 2 rows and it has 3 columns. So what would be the product is that the product C inherits the number of rows of A and the number of columns of B. So the product C has how many rows? It has 3 rows because it will inherit the number of rows of A and it will have the number of columns of B. So because B has 3 columns, so therefore C will inherit the number of columns of B. So it will be 3. So we have the product C, 3 by 3. Simple. Just don't forget that. If we're going to multiply AB and it has M row n column and B has n row and P column, C will inherit the number of columns, the number of rows of A, and it will inherit the number of columns of C. So, B. So C will have 3 by 3. It has 3 rows and it has 3 columns. Simple. Very simple. So this product operation is defined in this equation. So Cij is equal to, remember this notation? So this is the summation of the products of A and B. So this kind of notation or statement, mathematical operation or formula may seem to be so high, okay, but for better understanding of this equation, we will talk about the 2 methods, the dot product and the element-wise product or the Hadamard product. So for better understanding of this formula. So let's talk first about the dot product. So remember this, don't forget this one, the Ij, Ik, and then Kj. Okay, so the dot product between 2 vectors. Okay, again, we will first have the dot product. So the dot product between 2 vectors, for example, x and y. In this case, we have A and B, who have the same dimensionality, is the matrix product of x transpose y. Okay, so let me repeat that. This is very important. The dot product between 2 vectors, for example, x and y. In this case, we use here A and B. The vectors A and B, who have the same or which have the same dimensionality, is the matrix product x transpose and then y. What is the meaning of this? So in our next lesson, we will learn about dimensionality, but as far as this lesson is concerned, we will think of dimensionality as the number of columns and the number of rows. So if it has one column, it has one row, then it has two dimensionalities. So, and also as of this lesson, we will think first transpose as making the columns the rows and vice versa. So there is more technicality in this kind of process when we are talking about transpose. But again, for the sake of this lesson, we will think of transpose as making the columns the rows and the rows the columns. Okay, so in the future we will have more about that. So it means to say that, okay, so here, here, this is vector A multiplied to vector B. Okay, so we said again that the product is the transpose. So what is the transpose here? So as you could see, in our process, we have eliminated the column, the A vector. So what we do here is that we make this just like a row. Okay, so basically what we do here is compute Cij as the product between I of A and the column j of B. So it means that the first value of A is multiplied to the first value of B, which is here in this case 3. So 1 times 3. So 1 here is the I of A and 3 is the j of B. So let's go back first. Remember this one? It's the I of A and the j of B. So that's the meaning of it. J, again, here is the column. So this column, right? So, and then the second value of A is 7, and the second value here is 4. So we're going to multiply that 7 times 4. And then lastly, we have the last elements. A is 8 and B is 7. So that is 8 times 7. So our formula now, we have 1 times 3 plus 7 times 4 plus 8 times 7, which is equal to, of course, 3 plus 28 plus 56. And then when we total them, they become 87. Okay, simple. Yes, that's simple. Okay, so it means that the elements corresponding to some row or to the same row and column are multiplied together and the products are added such that the result is a scalar. So as you could see here, the result here is a scalar. 87. One number, a single number, and again we said that a single number is a scalar. So from two vectors multiplied together, we have arrived at a scalar. Simple? Yes, simpler. Okay, so as you could see, the order of vector does not matter. Just the number of elements in both vectors should be equal. So if there are 3 elements here, there should be 3 elements here. So that is also one of the requirements. Or else there would be some kind of chaos. For example, if it's 3 and then we have here 2 elements only. So to what element are we going to multiply 8? Of course, there's nothing. So okay, but in our future lessons, we're going to go higher on how we're going to do with that. So now let's go to the Hadamard product. Okay, so short background. Hadamard product is also called the element-wise multiplication. So this is very similar to matrix addition. And what we do here is that the elements that correspond to the same row and column of given vectors or matrices are multiplied together to form a vector. Again, let me repeat, that's very important. What we do here is that the elements that correspond to the same row, okay, and columns of given vectors or matrices are multiplied together to form a new vector. So another point to consider is that the order of matrices and vectors to be multiplied should be the same, and the resulting matrix will also be of the same order. So to concretize our ideas, let's examine this example. So we have the matrix G, the matrix H here. So we're going to multiply them. So what shall we do? So let's go to the first value of G, and then let's go to the first value of H. So basically what we do here is that we're going to multiply them. Again, the rule is that whatever are the corresponding values should be multiplied together. So 3 times 1. Okay? And then the second value for the first row we have the 5 and 6. The third is 7 and 3. So these values are multiplied. Then let's go to the second row. So 4 times 0. Then we have 9 times 2. Then we have 8 times 9. So 3 times 1, of course, is 3. 4 times 0 is 0. 5 times 6 is 30. 9 times 2 is 18. 7 times 3 is 21. 8 times 9 is 72. So our new matrix is now this one. Okay? So that's it. That is how we do the Hadamard product. So as we go along with our discussions, if we go to higher processes, of course, there will be some kind of additions into this. But don't forget about these basic things. Okay, so to make our understanding more significant, it is better for us to discuss the many useful properties that make mathematical analysis of matrices more convenient, of course. So we have two characteristics or properties of matrices that we have to take note of for us to be able to understand multiplication of matrices and vectors. Okay, the first one is that it is distributive. So as we can see here, we have A times the quantity of B plus C. So we have A plus B, then equals, what did I say? I forgot. Again, we take 2. A times the quantity of B plus C is equal to AB plus AC. So distributive, very simple. We just distribute the value of A to each matrix inside the parentheses. Okay, so that's it. Then we have associative property. So just by the word association, so we just associate. It's very simple. Okay, first we have AB, and then we also associate A and B. Before it's B and C, then second it becomes A and B. Okay, so however, this cannot be commutative. While it is true that multiplying vectors and matrices could be distributive and associative, it cannot be commutative. Okay, so the condition AB is equal to AB does not always hold, or is not always applicable, unlike the scalar multiplication, but the dot product between vectors is commutative. So why do we have to study this? What is this for? This concept of multiplication of matrix and vectors are used in image compression techniques such as JPEG or JPEG. It is also used in short-term memory cells of recurrent neural networks, or RNNs. So after all being said and done, let's try this. How do we multiply matrices and vectors? What is a dot product What about a Hadamard product? At the comfort of your home, make your own example of dot product and Hadamard product. Write your answers in the comment below. Do not forget to subscribe, like, and share. Please click the bell button to be notified every time we have a new session. See you in the next lesson.